Hello and welcome to lesson 7 of unit 7. We're going to take a pretty significant step up with factoring here. So we just got done factoring when a was 1, but now we're going to factor when a is not 1. So just a real quick recap of what we've done. Factor x squared plus 10x plus 16. We wanted to find two numbers that multiplied to 16 and added to 10. So that was, hopefully you can get that pretty quickly, x plus 8, x plus 2. And that was the factored form of that trinomial. So one of the things that I just talked about in lesson 6 was why were we allowed to just put x and x in as the first terms? Okay, we just kind of assumed that was the case. It's the only way to multiply two terms and get x squared. Now, how about this one? 6x squared plus 19x plus 10. Are we allowed to put x and x in as the first terms of the binomial? No. Hopefully you catch that pretty quickly. You can't just do x and x, because if I did, I would get x squared. I don't want x squared. I want, or we need our first terms to multiply to get 6x squared, not just x squared anymore. So that is the big difference here, is the number in front is no longer 1. It's a different number. Okay, so we're going to do this problem, actually finish it later in class, or later in this notes. So when the a value is not 1, factoring becomes more difficult. I'm not going to lie. Follow this process. First thing you want to do is always check for a GCF. We've done this before back in lesson 3. If there is one, take it out, like I said, lesson 3, and factor what is left over. Sometimes that'll be an easier problem, sometimes not. You'll see both examples of that on the back. Okay. If there is not one, move to step 2. All right, so we'll go to step 2. If there's no GCF, we're going to do something called factoring by grouping. We're going to group terms together to figure out the factors. All right, the first step is we're going to multiply a and c. This is a new step. We did not have to do this yesterday. Why? Because a was 1. 1 times c is just c. I didn't have to do that. Okay, so this time a is not 1, so we have to multiply a times c to figure out what we're going to factor. So we're going to find the factors of a times c. So you're going to find the factors of ac. Okay, and you're going to write a 4-term polynomial. All right, you're going to group the first 2 terms and the last 2 terms and find the GCF of each. The good news is, if you've done it correctly, the remaining terms inside the parentheses should be the same. If they're not, you did something wrong. Okay, we're going to practice this on the back. So we're going to do some problems. It's going to make a lot more sense as I go through them. All right, so factor each of these trinomials. The first step, like I said, was to check for a GCF. So I always put, is there a GCF here? If there is, take it out. And yes, there is. I can take a 3 out. So I'm going to do that. I'm going to divide each of these by 3. Whenever I do that, I'm going to put the 3 down on the line, okay, because I don't want to forget to write it. When I divide by 3, though, I get x squared plus 4x minus 5. In lesson 3, that's where we stopped. In lesson 7, where we're at right now, we can actually go further with that. This problem is what we did yesterday. This is my new problem. I'm ignoring the 3 at this point. And I'm going to find two numbers that multiply to -5 and add to 4. I'm going to pause for a little bit, see if you can figure out those two numbers. Because a is now 1 again, I can just put x and x. And the two numbers are +5 and -1. So there's my answer. Okay. Number 2, is there a GCF in this one? Take a look. There's not. So now what do I do? A times c. So 2 times 2 is 4. So I want two numbers that multiply to 4 and add to 5. So multiply to 4 and add to 5, that would be 1 and 4. So now what I'm going to do is I'm going to write this. Pay attention to what I do here. This is the 4-term polynomial part. The first term and the last term stay the same. All right, first term, last term stay the same. The middle term, I'm breaking it up into 1x and 4x. So there's my 4-term polynomial. I am now going to split it down the middle, and I'm going to find the GCF of each piece. So 2x squared and 1x, I can divide each of those by x. 2x squared divided by x is 2x. One of the x's cancels, right? 1x divided by x is just 1. I'm going to do the same thing with the second two terms. The GCF of those two is 2. So I'm going to take 2 out, positive 2. 4 divided by 2 is 2x. 2 divided by 2 is 1. And you can see the inside of the parentheses is the same. Okay? The GCFs, the two GCFs that we found, make up the first binomial, or the second. Doesn't really matter how you write it. So that's x plus 2, and then 2x plus 1. And that's my answer. And you can see that if I write it out like that on the line here, they are not both x and x. There's one x and there's one that's 2x, which we expect because we have to multiply to get 2x squared. You could FOIL that out, and you could find that that does give you the original problem. Okay. We'll do that again. I know that's a lot. I know it's probably a little bit confusing. We'll do some more here. It's number 3. First thing I'm going to do is check for a GCF. Do I have one? I do not. So now I'm going to do a times c. So 6 times 7 is 42. I want two numbers that multiply to 42 and add to negative 23. So what do we got here? So I can't find them right now off the top of my head. So I'm going to go ahead and start listing the pairs. I know they both have to be negative though. So negative 1 and negative 42. Nope. Negative 2 and negative 21. There it is. I'm going to keep going though. Negative 3 goes into 42 14 times. 4 doesn't go in, 5 doesn't go in, 6 goes in 7 times. That's the one that makes it. So now what I'm going to do is I'm going to rewrite my trinomial as a 4-term polynomial. I'm going to split my negative 23x into negative 2x and negative 21x. And then 7 goes at the end. Now, what if I had written negative 21 first and negative 2 second? Would that change anything? It wouldn't. You would be able to get the same answer. I can show you in class if you want to see that. But trust me, if you switch the two, if you write negative 21x first and negative 2x second, you're going to get the same answer as long as you do it correctly. Let me back that up. I'm going to include that negative with the 21, so I'm going to keep that, make sure you can see that. For the first two terms, the GCF is 2x, so I'm going to divide by 2x. So 6x squared divided by 2x is 3x. Negative 2x divided by 2x is negative 1. Okay. I want my first term to be positive once after I divide. So I have my GCF as 7. I'm actually going to make it negative 7. So I'm going to divide these both by negative 7 because I want that first term to be a positive. I always want that. So negative 21 divided by negative 7 gives me 3x. 7 divided by negative 7, negative 1. If I divided by positive 7, that inside the parentheses would be negative 3x plus 1, which wouldn't match the first one. It wouldn't be completely right. Now, essentially what we're doing here is we're factoring out a 3x minus 1. So if I take a 3x minus 1 out of there, what I have left in the first one is a 2x. And what I have left in the second one is a minus 7. Quicker way of doing that is 2x minus 7. Just put those together to make your second or first or second binomial. It doesn't matter which one where you put it. So 3x minus 1, 2x minus 7. You can factor that back out or FOIL it back out. Sorry, factor is not the right word there. FOIL it back out, and you'll find that you get right back to where you started. All right, let's switch colors. Number 4, is there a GCF in this one? If there is, let's take it out first. Yes, there is. I can take out a 2x right away. So I'm going to take out a 2x from each of these. And I'm going to make sure I put that GCF down here because I can't forget it in my answer. 2x to the third divided by 2x makes x squared. Negative 12 divided by 2 is negative 6. X squared divided by x is just x. Negative 32 divided by 2 is negative 16. X divided by x is canceled. I already accounted for the 2x down here, so now my focus is just what's in here. Two numbers that multiply to negative 16 and add to negative 6. Why do I not need to worry about multiplying a times c here? Well, because a is 1. 1 times negative 16 is negative 16. What are the two numbers? It would be negative 8. And I'll show you that you can group, even when a is 1, you could group them. Negative 8x and 2x. So I'll group, I wouldn't need to group this. The answer at the bottom here is x minus 8x plus 2. But I'll show you that you can group it anyway. So I'm going to take an x out of this. Divide by x, I get x. Negative 8x divided by x is negative 8. GCF of 2x and 16 is 2. 2x divided by 2 is x. Negative 16 divided by 2 is negative 8. And there it is, x plus 2. See it down there. And x minus 8. Okay, all of this was unnecessary for this problem because a is 1, but I wanted to show you that you still can. I'm not just making this stuff up. All right, two more problems. And I promised you number 5, that's the very first problem that we looked at, or one of the first problems we looked at. I said we can finish it later in the notes. Here we are. Does this one have a GCF? No, it does not. So I'm going to do a times c. So 6 times 10 is 60 and adds to 19. I know that those two numbers are 4 and 15. So I'm going to split up into a 4-term polynomial. 4x and 15x plus 10. And now I'm going to GCF the first two. That would be 2x. 6 divided by 2 is 3. X squared divided by x is x. 4 divided by 2 is 2. X divided by x cancels. Second 2, the GCF is 5, positive 5. 15x divided by 5 is 3x. 10 divided by 5 is 2. And so my answer is 2x plus 5, 3x plus 2. Okay, and I'm going to do this very quickly now. I'm going to show you that if I had switched this around, the 4-term polynomial, I would have gotten the same answer. I'm going to put 15x first, 4x second. Okay, so then GCF on this one would be 3x. 6 divided by 3 is 2x. 15 divided by 3 is 5. GCF of the next one is 2. 4 divided by 2 is 2x. 10 divided by 2 is 5. Look at you got 2x plus 5 right there. And then the first term's 3x plus 2 right there. You get the same thing. Okay. You don't have to do it twice. I just want to show you that it happens. All right, last one. Is there a GCF on this one? Yes, there is. I can take out 6 on each of these. So I'm going to divide by 6. So I have 3x squared minus 2x minus 1 with a 6 out front. I don't want to worry about the 6. I'm going to put it down here on the line. I can ignore it now. I still don't have a is 1 though. So this is one where I take the GCF out, but it didn't get rid of it. It didn't make it an easier problem necessarily. You still have to do it. Now I'm multiplying 3 times negative 1. I need two numbers that multiply to negative 3 and add to negative 2. That would be negative 3 and 1. So I'm going to write that 3x squared minus 3x plus 1x minus 1. 3x is my GCF here. Divide by 3x, so it's going to be x minus 1. GCF of these is just 1. There's no GCF, so it's just 1. And divide by 1 is just x minus 1. So 3x plus 1, x minus 1. All right, so we're going to spend a couple days on this. I know it's a little bit confusing. I think with practice, though, it becomes much, much easier. We have one more lesson in this unit, and then we'll be done with Unit 7.